Hey Ian,
Hey,
how's it
that's
going?
good. Excited to be here.
You and me both. How's everybody doing out there? Glad to see folks from really all over the world.
Yeah, all different times too. People waking up early, staying up late.
Well, we better make it worth their while, right?
Yeah, I think so.
Well, luckily, we won't have to do much work. We've got this this really fun new visualization library that is going to do most of the work for us. And I'm really excited that this is sort of the first time we're doing more of a workshop structured stream. So rather than typing as quickly as we can to show all the bells and whistles, we're planning on moving at a pace where people can follow along. We'll try and keep track of questions here in the chat. And we've got a good handful of observable folks in the chat as well to help troubleshoot.
Yeah, it's gonna be really cool. And I think the materials that we have, right, people can interactively follow along. I'm also excited to try this out, and hopefully, folks, learn a thing or two.
Well, should we get started?
Sure.
All right, I'm going to go ahead and start sharing my screen. We are going to be working out of two notebooks today, exploring two different data sets about penguins and the weather. Phil and Ian have done an incredible job putting these together as worksheets, tutorials, sort of these learning platforms where you can move through and get some hints along the way. So the first thing I'll do is share this notebook. So that is the link, which I'll also go ahead and put in the chat. So if what you want to do is follow along, is you can sort of follow my steps that I'll take right now and create your own fork, your own copy of this notebook. So if you head on up here, we're going to leave this original alone rather than Ian and I editing this one. I'm going to go ahead and fork it. I guess I'll just add it to my personal account here. All right, so Ian, I think you have worked with this data set a good bit more than I have. Tell us what we're about to dig into.
Sure. So the the penguins data set is an open source data set that is actually kind of prepared for learning or teaching purposes. It's a real data set of like real penguins. They measured various aspects like bill length and bill depth from several species on several islands, I believe near Antarctica. But it has some nice properties. Like it's not super big. Like there's I think 300 something penguins. There's some missing data, so it kind of, you run into real world issues where it's never as clean as like the first example that you usually do. And the fact that there's these numerical dimensions, right? These measurements of aspects of the penguin, and these categorical dimensions, like what island they're from or what species they are, lets us use many common data viz techniques to explore the data. And so I think, and that's what we'll do with Plot today, is be able to look at it.
All right, so I think you've done a great job writing up where the data are from, so we understand it. We also have this awesome drawing to understand what these different measurements are. And then one of the first things that you had prepared in this notebook is a table of the data, so we can get a sense of what those columns are, what some of the sample values are. So each one of these rows, we've got an individual penguin and these physiological measurements about their bill length, depth, flipper length, and so on. What's great is you have started writing out a series of questions, right? The reason that we do data visualization is so we can learn about these data sets. And we have these prompts for doing things to understand at first, the distribution of one of our continuous variables. And we've got some starter code in here for anyone. And what we can do is we can choose what we want to put on the x-axis here. Well, instead of ... you're encouraging us to check out body mass. And magic happens. Do you want to walk us through the code a little bit, Ian, of what this is doing?
Sure. Yeah. I guess there's a few things. Actually, there's a lot of things happening, and we're going to try to maybe introduce them one by one. The first thing you'll probably notice is plot dot dot, right? Like a dot is a little circle. So that's a mark. And a big part of the way plot works is that you're trying to encode data into graphics, right? Sort of grammar graphics style API. There's several marks in the plot API, like dot for circles, there's rect, and there's others that will, line that we'll cover. But that's one of the first concepts you're going to want to use, of course. And then there's the data. So we tell it we want to plot this data, right, with this mark. But we have to tell it a little bit more, like where we want to put those marks. So the X property, and anyone familiar with D3 may recognize this pattern a bit. I believe, Vega Lite as well, which reminds me that we have a couple articles we'll have to share in the chat about how plot is related to those two. Anyway, I digress. X is telling plot for the X dimension, right? Going left to right. I want to use the body mass column from our data set, right? So when we look at the penguins, you chose body mass. So every penguin has a body mass value, and that's what we're showing. We're placing a dot. We also use a CSS color, black. You could easily use a hex code for the fill. And then the fill opacity is what it sounds like. It makes them slightly transparent, right? So really this example, or this question is set up to get us the basic syntax of using plot. As we move on, this is probably not the chart you want to see about penguins. So we're gonna, I think, get there. But we'll keep introducing more things that you can do. And one of the interesting things about this is that there's still a lot of defaults that plot is doing for us here. And so as we go, we'll kind of talk about what those are and like how you can override those piece by piece to customize and make like a really flexible visualization.
Great. So Plot is an open source library. You can use it in a JavaScript application. One of the things that I really like about using it inside of Observable, when we don't have any loading issues here, is that we have the responsiveness set up across different cells. So if you change something in one place, it'll update in another place. One great way to do that is what we can do is we can create a select menu. And we could select between our different columns. So if we just say data.columns inputs.select, you can see that we can choose any of those different columns from the data set. But we can choose to store this or expose this in a variable. Let's just call it X. So then this variable X or this cell X can be referenced, and it'll hold the value that you've selected from the drop-down menu. So if what we want to do is make this a dynamic exploration, is rather than say that we want to see body mass, we can just say that we want to see whatever is stored in X. So we can see those islands. All those dots, of course, are just on top of one another right now. We can look at the distribution of bill length and see some of these larger outliers. Same with bill depth. And our initial question of body mass is what we've got. So this gives us a really nice workflow for flipping across these different options and exploring different aspects of our data set. Should we keep going?
Keep going.
Let's keep going. As we scroll past, I will show this wonderful feature that you created here to include a hint and solutions.
I do want to say that Philippe Riviere actually pioneered a lot of this worksheet. I mean, the penguins one for sure, and the structure of doing that. I want to give him appropriate credit. Phil has also contributed quite a lot to the plot library itself. So thank you, Phil. Anyway, yes, the feature is great though. I will give you that. So sorry for that.
No, thank you for that attribution. Something that we're all thinking about is how to list multiple creators on notebooks to more clearly service those contributions. So This feature that you all had created is the ability to show a hint. So we can see a suggestion of what code you can write, as well as some different solutions. So here we have 2 different examples of showing body mass and flipper length, and you could copy one of these lines of code. So if you weren't following along here in the workshop, you could easily access that information. All right, so we've shifted from exploring a single continuous variable to wanting to assess the correlation across different variables in this question that's posed about the relationship between flipper length and body mass. And we have a similar structure here where we're going to be creating dots, and we can, again, choose what we want to have on each one of our axes. So we could select body mass along our horizontal axis and flipper length along our y-axis.
All right.
So we've got our dots again. This time they're not only positioned in 1 dimension, but positioned in 2 dimensions. And not surprisingly, the heavier penguins have longer flippers. We might even want to think about that in reverse. Maybe we think that flipper length is more driving body mass, so we could switch those around. So there are some heavier penguins over here that have pretty short flippers. We have some penguins with some really long flippers. This maybe fits a mental model about what I understand about penguins and how heavy they are, what they might look like. I'm just going to scan over here. I do see a lot of activity in the chat, which is great. I think a lot of the observable folks are surfacing or responding to different questions.
Yeah, I'm keeping an eye. So far, the chat is answering the chat. But actually, Maya just asked a good question about the vocabulary. So X, fill, and fill opacity are plot properties, and their values are columns in the data. But what do we call them? Channels. That's a excellent question, because let me
excellent question. Why do you say that?
Let me fill you in on. Sorry. Let's see. I believe the scales documentation, the scales notebook, which I'm going to post in the chat while I talk about this, has a little bit more detail on channels. The options, like if you think of that JSON object of the X, the Y, and the things, you think of as the options you pass into a mark. They drive a lot of stuff. There's a limited number of channels. So X and Y are like the most common channels. There's also a color channel, and which I think the next question might get into. And I think there's a couple others where basically a channel is anything where you can drive it by the data. So I think some property, like the radius, the R property of the dot is a channel. Yeah, so each mark will define as channels, and actually the documentation, which you can find in like the collection of plot notebooks, also put that in the chat, like links out to each of the marks, but the README of the repository of the plot code also has a nice structure to like quickly be like, okay, what are the things that I can assign data to for this kind of mark? And then the other options are things that like you can configure, I don't know, something like stroke width, or if you use a text mark, the font size. And some of those things you can choose to just hard code it, right, where like every mark gets the same value. Or if it can be a channel, you can assign data to it. And by assigning data, we'll get into that a little bit later. Usually you just give the column name, right? That's the quickest way to do it. You could directly pass an array, or you could also give an accessor function. And we'll show an example of the accessor function a little bit later.
Great. So we're starting to see that in this same object, we're actually driving some visual choices with the data itself, and others we can apply static values. Like here I've set the fill to blue, which obviously isn't part of our data. It's just gone ahead and made that intelligent choice of filling all of these in with the color blue. All right, so now we've got our two-dimensional exploration here. Now, as we add another layer of complexity, we can ask about the relationship between these two continuous variables as it occurs across different categories, right? Is this relationship, does it hold true across the different species? So something that I like to do when I'm writing code is copy some code that I know works, like the last code that I wrote in this case. So we can start with this same plot. And we want to know whether or not this is true for each species. We already have our horizontal and vertical positions selected. So rather than just set the fill to be blue, what if we instead use the species? And now we can really quickly see that we have one species that has longer flippers and is heavier, and then two other species that are sort of intermingled with lower body mass and lower flipper length.
Nice. Yeah, and so in this case, the fill is a channel. Like we're driving the color by the species column.
That is a really good clarification. But it gets better. Can it get better, Ian?
I think it can, yeah.
So a really wonderful plotting technique as you're analyzing data in different groups. One we can see here is to use different colors for those different groups. But another is when you create small multiples, so the same repeated graphic for each one of those groups, which has been referred to in other visualization libraries as faceting. And we've carried over that language of breaking your data into different facets. So if we think about looking at these relationships by sex and by species, we could try and take this initial plot that we've created and break it out into different facets, different small plots. So I will again, well, maybe I'll start from scratch here as an educational exercise. So we know that we want to create dots. And can we, so we do need to pass in some data. I'm seeing sort of how little code I can write and still get some sort of reasonable visual output. So we do get this blank plotting space here to show up if we just pass in our data to this visual mark and call this rendering function .plot. We then, again, sort of declare our different options or these channels that we want to use. So we wanted flipper length. And we can see what that looks like. Again, we just have that distributed out along a single axis. We add in our Y channel of body mass. We can now look at this data in 2 dimensions. We can add fill, another channel with the species. So we have our third dimension in our data here. And to break this chart out into different facets, we're actually going to move down into this .plot function and pass in another object of options here. So this is where we start to get into our customization. There are a lot of things that we could start declaring in here, like maybe we want the margin left to be 100 pixels. If you need a little bit more spacing for your scale ticks, your axis ticks, or your labels there. And we can also say that we want to facet this out. So this requires, I believe, 2 things. One is the data that matches the data that we're using, that we're going to use to describe how we're going to break it into different groups. We just call data. And then we can break this out either horizontally or vertically in 2 directions that we know commonly as X and Y. So here, if we choose the X direction, we can say that we want to break this plot out into different subplots by sex. And if I remember to put all the commas in the right place, which is a rare occurrence, we can see how these how the data set breaks down into these different areas. So we can see our female penguins, our male penguins, and this is the first time that we see some of that real world data missingness. I imagine that this is where we just have blanks in our data set. So there's actually nothing labeled up here.
Nice.
And this, maybe to zoom out to a conversation about plotting libraries, Ian, you and I think are passionate D3 users, have been for a long time. And what I almost want to ask an emotional question, like how do you feel when you can go from a single chart to 3 charts in that additional 1 configuration here?
I mean, there's joy and grief. I think the joy is what you get. Like it's fun. It's immediate gratification. The grief is all the time that I had to spend doing it the hard way for all these years. And yeah, I mean, but seriously, it's pretty exciting.
Yeah.
I mean, just to someone in the chat, carrots and pizza, which is an interesting combination. Both go good with ranch, I think. Anyway, asked, can you do facets of facets? Could you do more dimensions? So why don't you try just adding a Y island or something?
No way.
Yeah.
Say it isn't possible, Ian. Oh my goodness. So let's pause for a second. We are looking at the relationship between flipper length and body mass repeated for each one of these different combinations of sex and island that they came from. And then we have the color encoding for these different species.
Yep. Yeah, you start to see those relationships pop out. The one thing that I think would make this a little nicer is if we framed each of our charts, which we can do pretty quickly as well.
Yes, if I am correct, we can add additional marks down here.
Yep.
And if I want to put just a frame around each of these, do I say plot.frame?
That is correct.
That just it's really amazing, right? The amount of time that I would have taken to try and measure the outside of the SVG and draw a rectangle that it's that size.
Yeah. Calculating margins and scales and stuff.
Yeah. So to ask a bit of a provocative question, Ian, does this mean that you're done using D3? Have you put down your D3 skills for good now? I'll scroll down so we can see the code.
It's funny because actually I think it's the opposite. Like, somebody in the chat just asked a very relevant question: is can we do shapes for different species? And part of the answer to that is you can extend plot with D3. So all of the plot marks shapes are actually written in D3 under the hood. And there's ways that you can implement your own marks, make plugins for plot. We're working, this is a 0.1 release, right, of the library. There's a lot of things we know we want to add, and features that we'd really like to see, but also we're putting it out there to get feedback from people using it, see how to focus. But definitely you can really take a plot to D3 land, if you will, if you want to do that. So the answer is that I will be using plot very often and very frequently. And then when I get to something that I want to polish, really customize, tailor it to the story, I would probably then switch to D3, or depending on how reusable I want to make that, I would extend plot.
Great. And there have been a couple of specific questions about legends. I think that is very much on the to-do list so that we can, by default or with a small additional configuration, show the color legend. That is something that is very much in the pipeline.
Absolutely. Let me also link in the chat the just the issues on the repository. Like there's a lot of enhancements tracked there. And, if people are curious, pull requests are welcome as well. It's the code is quite well written, and, feel free to take a look. The other thing I want to share also, since I mentioned, we talked about D3 thing, is the plot for D3 users.
Yes, got that across the bottom of the screen. So Ian, I had not actually forked this. We are now actually working together. It looks like perhaps some of our network issues have been resolved, which gives us a great opportunity to review, because my code has been lost.
Oh, did you refresh?
So I did refresh without forking it. So I would like to, I think this is a great one to actually re-walk through, in the spirit of this being a workshop, sort of moving through these particular pieces as a review and surfacing any questions in the plot in the chat.
Okay, great. And then also for people watching and like wanting the code, right? Like often that thing I just want to remind that the solutions under each question have the working code that we're like working to build. So even though we don't have what you typed this morning, like the anyone who gets stuck trying to do that, like if you want to go and do this later on your own, you can always use the hints and the solutions to figure out what you might be missing.
All right, so to sort of walk through this building up of a plot, we again pass in our data to the type of mark that we want to create, a dot mark, and declare each one of these visual channels. Thank you, Maya, for giving us that language or vocabulary specification. And then to break this into different facets, we come down to this dot plot function and describe what we want to do. We can pass in the data and then say horizontally, we want to facet this out by sex, and that vertically, we want it to be broken out by island.
Nice.
A little bit messy. You had suggested that we add some additional mark. Oh, we can start collaborating in real time.
Yeah.
You take it away. What's great is we start to actually learn about these data sets, right? That there are only certain species on certain islands.
And then someone in the chat, Ananya Roy 22 pointed that out. No island has all three species.
Oh, nice.
And one island only has one species, the Torgensen.
Yeah.
I'm also going to customize a couple things. So one thing I like to do is make them full width. By default, it's sort of the like paragraph width. And then we'll add like a little bit of margin, right? Oops. And this is an interesting thing. So we haven't mentioned this, but you can override the scales. So like the X and Y, you could control the domain and range, which I think we'll get to in a later example. But the facet has its own sort of thing here. I think it's this. Is it target? Oh, no, sorry. It's not the facet scale. It's actually, it's only been out for a couple weeks. I'm still learning.
Aren't we all?
Okay, that's a lot. So you can configure the facet as well. And that, I believe, is documented in the README more thoroughly. And there's a bunch of, like we mentioned, there's a bunch of these. This is also the same as doing width, where is the default variable and observable to give you like the responsive screen width, but we could easily do.
Great. So we have another question about whether or not we can filter this down. I'm personally excited about working on some good data wrangling materials for how we can manipulate our data. But one thing that I think we could do is when we pass in our data, someone suggested that we only look if we have sex defined, so we lose this third column. What happens if we filter this down with each element in our array and say that d.sex is not equal to empty string. Oh,
I think it's NA.
Like
as a string. No, it's a string. That the string value is NA. Yeah.
Ooh, now, this is interesting.
Yeah, this is a good thing to point out, because the facet requires you to also pass in the same, like the
same data
that you're passing into the mark.
So what we might want to do, because we're repeating that in both places, we might want to say, chart data is that. Right? We can take that data and filter it down so that d.sex 344, 344.
Yeah, I think it's NA. Yeah. Oh, maybe it's not. What is? I guess we could look in the table real quick at the top.
Is NA not is?
Oh, it's
NaN.
Blank. I think it's just. Oh, I can edit
doesn't equal
it, right?
Undefined.
Yeah, the way you can do. Yeah, JavaScript is strange. Let's try this.
No, that is some wizardry.
Not d.sex would say, like, anytime d.sex is false, then like, right, in the case of a string, if it's an empty string, it's false, or if it's like a null or undefined, it's false. And then if we do a not again, we're only keeping the things that are like strings that have something in them, is what this is doing. So hopefully it's not like more confusing.
JavaScript oddity, filter down any missing.
Yeah, the issue is sort of a JavaScript one where there isn't really a great way. Oh yeah, so we have to say data : chart data. What?
Oh, we have an extra parenthesis. The joys of coding together.
Nice. There we go. So we got rid of our thing, and maybe I'll take the width off. That's nice.
Yeah. So this is really a rapid opening up of the data, right? That we have this syntax, and it isn't just about the lost hours spent creating D3 plots, but it's about really quickly surfacing these different comparisons or being able to make these different comparisons.
Absolutely. I want to catch up on a couple of questions now.
Please.
A really important one is from buddy Chris Henrik, who says, when will Plot support 3D pie charts? I think for that, you have to go to Peter Bashai, right? I saw him working on a really nice one. Seriously, though, right now, Plot doesn't support radial scales. I think it is on the list of things to support. So while you probably won't get a 3D pie chart, and we all know that you shouldn't, there probably will be a time where you can do radial stuff quickly, which will be nice. I saw another question. So the filtering one was there. Oh yeah, Map Chitra says, is there a way to get the D3 code behind the plot? Not necessarily. You can definitely download the SVG. So this does produce an SVG. You can click on the cell and download that. You can download it as PNG. It's always nice. But yeah, like the code behind Plot uses D3 to generate the SVG, but it doesn't exactly generate like D3 code to do that. And there's part of the reason is that this is a slightly different abstraction level. The way that, for example, facets work with everything is pretty, magical and intense. So like support, like you kind of just out of the box supporting that wouldn't quite work. But the idea that scales, like we'll see in some of the later examples, that we'll use some D3 functions that aren't necessarily DOM generators, but helpers with colors and time and that kind of thing to power our plot, like different scales. that kind of thing. Yeah.
Great. Thanks for catching up on those. Other questions?
Oh, sorry. One more.
Please.
When we change only width, why does it change the height of the chart? So Plot by default uses an auto height heuristic calculation, which is pretty nice. Like it works pretty well in a lot of cases. But you can manually override the height too. So there's another variable height we could set to just say, excuse me, let's see. I just make it like 200, right? I make it tiny.
It could be worse.
Or I can make it bigger. So right now, though, when I take away the height, Plot is determining that for me. I think this kind of goes in, like the general philosophy is that the defaults are pretty thoughtful and should always give you something pretty good to look at. Like a lot of the motivation behind Plot, I think, is like how quickly you can see the data. And once you see it, you can think about it in a different way. You don't have to imagine it, right? So even if it's not showing you the perfect thing right away, it's showing you something that should at least get you a step closer. And then you can tweak and like configure and override what it's doing rather than having to kind of like build it all from scratch.
Awesome. Some quick answers to questions I saw go by. Don't think that transitions or animations are supported. I mean, this is focused on data exploration, not as much data presentation or communication at that degree of customization. Am I right?
That is true. It's not a immediate focus. Yeah, and like as part of Observable, when using it with Observable, we rely more on the data flow to update things. So like as you showed with that dropdown, the plots like update instantly, and we're just optimized for speed. That said, it is possible. I've seen some experiments, but I think that the focus is definitely on exploration. So again, once you've explored and you feel like this is how I want to show things, and I want to show a transition, I want to take people through a transition, implementing that in D3 will be much easier because you've already nailed down almost everything that you might want to have to figure out while you're developing that D3 viz.
Awesome. Well, let's keep moving through some of this powerful functionality we've got here. So we have embedded in this simple question a prompt for a new technique where we want to know how many how many penguins of each species are present in the data set. And I would reach out for doing this calculation with something like tidy.js. Hey, Peter. But it turns out that we actually can do this inside of the plotting code itself, that we support different types of transformations where we can calculate these different types of sums or counts or means or other summary values that we want to plot. So we just want to know how many species there are, how many penguins there are of each species. Actually, this question is written backwards. How many species of penguin are present? So what we might want to show here is, rather than sticking to our dot representation, we can start to use a bar that goes in one direction or another. So let's just get sort of the structure set up where we hopefully get a blank canvas right there. So here is our data. And I think what we're going to want in the end is, along our x-axis, we want the total number of penguins of that species. And then along our y-axis, we're going to want our species. So if I were to try writing that out, I'd probably guess something like y species. I always miss a comma or two. And we can see that it's setting up the plot in a way that is moving towards what I want. But I still haven't done that sort of aggregation step of counting the number of species. And to do that, we've got another, should we call it an abstraction? I feel like I want to overuse the word abstraction.
Well, the term for these is a transform.
A transform.
In plot lingo. So there's several ways that you can transform you can think about it as transforming these options like this, like where all our marks take some kind of options, like where you set your channels. What the transforms do is they take in those options and they modify them. And they maybe do some calculations. And in our case, we're going to do some aggregation and then pass that back to the mark. So you'll see that you're calling plot.group inside the bar X, right? Like where the options are. So the plot.group returns back options.
Aha. So we're going to need some more information in here.
Yes.
So we know that along the Y axis, we want to show that different species. And I had said that we want along our X axis to show the count. Missing channel X. All right. Oh, I wonder, can we secretly just say group X? Oh, group Y?
There you go.
All right.
Yeah. Should we explain what?
Yeah, the secret is that you just switch those out until it works, right?
I mean, it's fast enough that will take you a long way, actually. And you'll see it. You'll see if it works or not. But yeah, to be a little bit more explicit. So in the second X, you don't want count. I think you want the because you have count, you don't need that. But in the options, you can think about that more as like what you're picking from the data. So that'd be more like, let's say you wanted to average the flipper length. So then the X would be flipper length. Maybe we should copy this into another cell. How about that? Here, I can do that real quick. This is something I find myself doing all the time now, is like once you have a plot that kind of shows you something, but you want to try something else, then you just copy it, make a new one. So then I want to calculate the flipper length on my x-axis, and my bar is the flipper length. Instead of count, I'm going to do mean. And then this actually should be group X, or sorry, group Y.
Group Y.
And I think that this one should as well, because when you don't specify the Y, it's trying to group by multiple things. And we don't want this count here. These count and mean, all those options are part of the group transform. Like I think about this first object as the output. Like what is my group gonna do for me? Like what's it gonna spit out, right? It's gonna put the mean of the X dimension into the X channel. So when I make my bar mark, it knows that, or like when it tries to figure out how long to make its bar, it's grabbing that value. That makes sense.
Yeah, that's great. And we, of course, can do some small visual tweaks here. We can get our margin left to be there. And we can also remove our Y label if we want, if we knew enough about this data set.
Yep. There's a question in the chat, which I think is a good one. It comes up all the time. This idea of like how to sort the bars.
Ooh,
instead
great
of,
question.
By default, it's sorting the Y dimension based, it's a categorical scale. So it's got these categories, the species in our case, and it's sorting them in alphabetical order. But we want to sort them by, let's say, the biggest number to the smallest. Now, I'm going to move this. Here, actually, let's do this. Let's make another cell. So for everything that we do, we'll kind of make a new chart. And you've already started customizing the Y domain a bit, right? And that you got rid of the label. We can also override the domain. And so the domain is like what the input data is. And right now, the domain is calculate, like plots defaults will pull the domain out of the data, right? Like it's using some thoughtful heuristic to figure that out. the first thing we can do is we can just manually do this, right? There's only 3 species. Let's say I want to do Gentoo chin strap and Adelie. Just to prove the point, like I can pass in a different domain, and the order of that will determine this, right? What you really want to do is have these calculated from your data. So, I mean, we could do that real quick. Like a common way to do that is with, like, there's D3 group sort. You could do it with tidy or with Akiro, right? Like whatever way you would normally count up, like do the group outside of plot, right?
Mm-hmm.
I think there may be an issue for, like, can we make it easier for plot to do this for us? I think part of the challenge with that has to do with facets and other things. But for now, I mean, I might actually say in the plot context, like this is the concept and it's an exercise for the reader to do it. What do you think?
Yeah. Is there sort of a internal way to access those calculated means? Like what we want is the mean, the species with the mean flipper length to be the first one. Can we access that information down here, or do we have to do our own, do we have to do that calculation elsewhere?
I think we have to do the calculation elsewhere. I will say there is this, I don't think this is really, I mean, it doesn't give, so that you can get some internals of like what it's actually putting in these, the data it has inside, but no, the short answer is you have to calculate your own.
Yeah, well, I think we can do this briefly, and it's a good demonstration of when to try and get one package to do something and when it's easier to bring in another one. So I've really liked using, what are we going to need? Tidy, mean, arrange, and descending, all from this package called tidy.js. And this gives us a vocabulary for data manipulation, very similar to what folks are used to in the tidyverse set of things in the R programming language. And I think what we could do is we can pass our data in there. We're going to calculate, we're going to have to group by and summarize, aren't we? So we can take our data, we're going to group it by species. And then inside of that, we want to calculate this new thing, which is the mean of the flipper length. So we can say, mean length is the mean of the flipper length variable. Group by is not defined. Camel case. So we've done that. And we should get those same 3 values. We get the mean length. We alternatively could have done this sort of calculation before putting it into plot. And to get our list, or this array of the 3 values, what we're going to have to do, now that we've grouped and summarized, we could perhaps arrange it in descending order by that column we created, mean length. And then we can ask Peter to create a new functionality called poll that just returns the column values of interest. But until then, we can just get d.species back. A long way of getting the same order, short by many respects. So we can do that over here, and then we could just pass that domain right in there. So sometimes great to leverage the magic of doing those calculations inside of your plot. And also we can bring in complementary tools to do that sort of data wrangling outside there.
Nice, nice.
All right, are we just about done talking about penguins? I'm ready to talk about the weather.
Yeah, yeah, we can. You want to switch to small talk after this much getting to know each other?
Yeah, exactly.
Yeah, I think that this could be a good time. There are still four more questions in this worksheet. We can, as the saying goes, leave those as an exercise for the reader or watcher. I think, personally, I'd love to hear what people think of these worksheets, like how the experience was, if they helped learn. So if you do go, like, each question gets a little bit more complex in terms of what it enables and the functionality. You can leave comments directly on like the original worksheet, or reach out to us in our various chat channels. Like the D3 Slack is one place to find us, the Observable Forum, that kind of thing. But yeah, I think that maybe we can move on to this next worksheet that we prepared that focuses a little bit more on time series and the kinds of things that Plot helps you there.
Great. Do you want to start sharing your screen, or should I continue to share my screen over here?
Yeah, I can share my screen. Yeah, we could switch over.
So we've got a link that I just put in the chat to this next notebook. You ready for me to share your screen?
Let's do it. Yeah.
Click.
Nice.
All right. So dare you try and fork this notebook and add me to it?
Yes, I do. Our team has been hard at work fixing the earlier latency issues. So yes, thank you, team. All right, and then I will share it with you. There you are, add you. So now we can both edit this at the same time.
Great.
All right, so this is a data set of daily weather measurements for Seattle for, I think, 4 years, which we'll see when we start visualizing it.
Sorry to interrupt you, Ian, but do you mind if I publish this so people can follow along in this notebook as we go?
Oh, yeah.
And we'll sort of publish it a couple of times. So this is where we will be doing work. Can I publish it?
I think so. Do I have to? Or
do you maybe have to, as you shared it with me?
Let's do public. Nice, you changed the title. All right, so it's published. So you should be able to share the link.
Great. So folks should be able to see. You won't see as we go step by step, but we'll sort of periodically republish this set of changes to this notebook.
Someone asked if we published the Penguin one. We haven't. Let me just.
Yeah, we also lost most of that work.
Yeah. Okay. I'll share the link anyway in the here. Oh, I don't know what that is.
Do you want to go get it?
Not really.
Great.
Oh, I might have to though. Here, do you want to take over the first question, and I'll mute myself?
All right. So we are switching gears to talking about the weather. I'm at your door, Ian, in the chat. So we've got this this data set. It was made available through the Vega Lite, the Vega Datasets project, collected from NOAA. And once again, we can look at this in a table. So we have all these different measures of the weather in Seattle. We have each date. I don't know about everybody else, but I sort of flinch when I think about working with dates. It's something that has taken a lot of work to get past in many different languages. By many, I mean the 2 or 3 that I'm familiar with. So we've got these dates, and then we have, is it raining? You know, how much did it rain? What was the wind speed? How would you describe the weather? And we've got our min and max temperatures there as well. So we can try and answer this first question here. We want to look at patterns in temperature over time. So a common structure for that is showing time along our x-axis, and then we can choose to share or to display along the y-axis something like the precipitation. So you can see that this notebook is introducing a bit of a different structure. Rather than declare an individual mark like we were doing with plot dot dot, here we're using plot dot plot, into which we can pass these different marks. So you can see in here, we're saying, well, let's use some marks to plot the data. And then in there, we're still using this API in the same way. We're looking at the date. That's promising with some nicely formatted axis ticks there. And we might want to see the minimum temperature along our y-axis. Noticing that this is year over year, it makes sense that the minimum temperature sort of rises in the summers and falls in the winters. I think the reason that Ian, welcome back, decided to use this different structure is he anticipated adding multiple different marks using different features of the data. So here we added one line for our minimum temperature. We can go ahead and add another line for our maximum temperature. And then we can also make these hot and cold colors, stroke red for our hot line, and then stroke blue for our cold line, though probably culturally oriented what those different colors might signal. So now we've got our starter plot here, and Ian is back. He's definitely going to be taking the lead on this notebook. So I'm glad that that you're here.
Yeah, it wasn't pizza, but it's no big deal. I'm ready to make some more marks here. That was referring to the chat. So yes, and that you're exactly right. Why we switched to this sort of syntax. Basically now everything we're doing is within this configuration, right? So we could, again, change the width and all that good stuff. And in this way, you do get like the order that you put the marks matters. When we do the plot line, like I'll just show this real quick. If I take this and put it here, like this is the way we were doing everything in the last notebook. The red line will end up at the end of the list, like it will be on top. So that's the only thing to keep in mind if you're building up a plot in that other way. So yeah, I mean, this is the basic idea for this question, right? And so you can see the highs and the lows, but it's pretty spiky, right? Like daily fluctuations can be kind of a lot. What if we want to see more general trends? There's another cool functionality of plot that we can introduce. So I'm going to copy paste, like we said, like we got something working. Let's bring it over. There's another transform, and it's the window transform. And so I'll explain how that works. So we're going to say plot.window y, because we want to do basically a rolling average, right? So like every day, the value of the temperature we want to put is not the actual temperature, but the average of like the last, let's say, 7 days, to sort of smooth things out. So to do that, we're passing the options into the window. And unlike the group, it doesn't have like an output thing. And it just has one parameter, which is the k. How many data points do you want to average over? So if we say 7, we'll see that like that line got a bit smoother. And so I'll just do the same thing for this one. And maybe in the spirit of using the inputs, oops, I need another closing parentheses to be a bit smoother. I think it would be fun to do kind of like you did where we say k is inputs.range, and we'll say 1 would be like not averaging at all, to, I don't know, like 60 days. What is that? 2 months. Large number. You can, if you want to make the step. And then I'm going to start the value at 7, which is like what we have it set to. So if I change this to just k, and if I like, this kind of unsmooths it, and then we can like smooth it out. That's pretty fun. Yeah, so that the window thing can be pretty useful. Let's, though, look at the next question, which is something you probably commonly want to do, is instead of just drawing 2 lines like that, I'm going to copy this, though, because I do believe in copy-pasting code. It's powerful. Because we want to use an area chart, right? So there's the line mark. We can do area Y, which is just a shorthand for doing this. And then instead, let's not do the line. So this isn't what I want. I want the area between the 2 things. So yes, instead of just giving it 1 Y value, you can give it the bottom channel and the top channel. So that's Y1 and Y2. So Y1 is the minimum and Y2 is temp max. And so that, instead of stroke blue, well, let's say fill gray or light gray or something, right? So this is the kind of thing, the area between those 2 temperatures, right? And then I guess our K, I'm going to leave it 28 day, smooth it out a little more. And I think the final thing of like building up, oh, you know what though? Just, I don't know, just looking at this, I kind of forgot. There's one really cool big that I like to use a lot is the grid. It's sort of just an axes option, works with facets, all that good stuff. But like, you know, I think it helps in this case.
So Ian, the visualization sort of academic in me wants to ask this question rather than looking at the area chart where we sort of have to look at each space and try and measure the distance between the top and the bottom. Can we just plot the difference between them directly? Like, can we plot 1 line that is the difference between the minimum and maximum temperature on each day?
Sure.
And I think that perhaps will introduce a nice new technique as well from the programmatic side.
Yeah, so another, let's say, so we're going to go back to the line, right? But instead of, and we'll keep it a window, but instead of Y1 and Y2, we still want Y. And this, actually, yeah, you're calling back when we said there's different, instead of just passing in the column names, we can actually give an accessor function. So I did notice some people are coming from other programming languages. This is a JavaScript thing where we're saying, like, we also type it out in the old school way, right? Where we're going to say D is like the data point. Where we want to say d.temp max minus d.temp min line. I don't want to fill it. I want to stroke it. So that's the difference. So it's it goes from like 5 degrees to 12 degrees. And then the sort of, more modern canonical way to do this is to write it with this syntax. Something I tend to do a lot actually is like put each of my mark options on its own line, and to like swap stuff out.
Yeah, and this is really interesting, right? On summer days in Seattle, there's often, we see this like 10, 15 degree difference between, the midday and nighttime. And in the winter, it's, 3, 4 degrees different. It's just kind of the day and night are one in winter in Seattle.
Someone did ask, is this subtracting the smooth versions or smoothing the subtractive version? This is smoothing the subtractive version. We're saying the Y channel's value is the difference. And then the plot window is going to modify that with the smoothing when it gets passed in, before it gets passed into the line. So that is the answer there. The other way, like now that we have this way of accessing stuff, we can go in and this question was like, can we show the daily average between the highs and lows, right? So if we do the area again, plot that area Y, and we'll keep smoothing it. So if the X is still the date, the Y1 is the min, Y2 is the max. Okay. That looks interesting. I need to fill light gray. And then instead of the difference here, I want to average them, which meteorologically may not be completely the right thing to do, but it does give us a sense of the trends. So, which tells us summer is hot and winter is cold.
Yeah. There is a question and now an answer about how JavaScript expands variables. This actually is some magic that I would love an explanation from as perhaps a deeper JavaScript expert than I am. What is this magic?
Yeah, so if you have an object, and I'm gonna like make a code block here. So if I say X is 5, right? Let's say I'm gonna make a new JavaScript object here. I'm returning an empty object. I could return X is X, right? But if the variable name is defined and the key is the same, then it will like fill in, like you can do that. So it's like a convenience thing that I could just say this stuff. I don't need to like spell it out. These two are the same thing.
Incredible.
Yeah. Let's see. All right. So yeah, we got this. I think this next question is one of my favorite things. It's a subtle functionality, but I think really powerful, really exciting. So let's take a look. So basically, what if we want to look at this trend over time, but we want to bin time, right? Like make a histogram. So with temperature, maybe it doesn't make as much sense, but something like precipitation, like how much it rains, it makes a little more sense. So if we want to know how much it rains every month, and we all know Seattle can be quite rainy, there's a really cool way to do that. So I'm going to start off just by, let's just start off plot.plot, because first I'll probably draw a line. Then I want to make bins, you need like rectangles and a bin. But let's first just make let's see, the X is date, the Y is, I believe it's just precipitation. dot plot. Oh, this is supposed to be marks. Plot. I forgot. All right, so we got some like spiky precipitation going here, right? This is every day. So we don't necessarily want that. And we could use the window function to average things out, but I want to like add it up, right? So instead of averaging out, I want to use a bin. Let's see. So the other thing, there's interesting is we have plot.rect. Let's say rect y. I'm going to make rectangles that go up and down. And there's also, you might have noticed before we use bar y. Think what's the difference between a bar and a rect, right? Like they're both rectangles. The idea with bar is that you use it with a categorical scale or an ordinal scale, right? Like where you have, I guess, discrete things, right? Like our species, there's like 3 species. So there's 3 bars, and like we can split the pixels into even groups. With binning, we have a continuous value. So like in this case, actually, we're using dates. So we're going to go a long time, and we're going to bin time into like chunks. And like the start and stop of those chunks fall on that time scale. So let's see what that means. The date, is still precipitation, but we want to, we're going to bin X. So we're going to bin on the time. Oh, didn't like that. Oh, I need to output. The Y is I want to add up the precipitation, right? And so here it's giving me bins, and it's used a heuristic, that, let's see, to determine what size these bins are. But I think what the like coolest thing is you can actually use D3, so you can set the thresholds. It's just like a bin if you did it on like any other measure, right? You can set the thresholds and how many bins you want. But this you can actually set it to like time, let's say week. And then I want every week. I want to bin by every 1 week. But you know, I can say every 4 weeks is kind of like binning it to every month. If I say month, that 6 months, every 12 months would be every year, right? So then we have like the total precipitation every year. This would be another case where
I knew you were gonna do it.
Yeah, is fun. Let's see, we'll go 1 to 12 for this. 1. And then you got it?
I got it. Good teamwork.
Excellent. So yeah, we can see how the bins. Oh, hello. What did I do there? 11.
Ooh.
Did I? Interesting. I have to ask about that. Is it creating for these like weird numbers? Is it creating different bins? All right. And if I do weeks, let's see, every week. I can do a lot, 52 weeks. Oh, yeah. Oh, yeah.
Have fun on each other's toes.
Nice. So yeah, you can kind of change the resolution of the binning. And in the end, we get the years. So yeah, that's pretty cool. Let's republish that. Nice. Yeah, so you use the D3 like intervals to set these bins. I think it's a really powerful technique for dealing with time series.
Yeah, I had this is from our conversation right before this, but I had previously confused when we group and when we bin. just like you were talking about, bars and recs. These are things that are related and importantly distinct. That when you have a categorical variable like the different species of penguins, that's when you're going to be grouping by those explicitly, versus if you have a continuous variable like time or like precipitation, you're actually taking those observations and dropping them in different bins of different widths along a certain value. So you'd bin those continuous variables or those continuous values, and you'd group your different categories.
Yeah, exactly. And I think I just want to point out that the rect and the bar notebooks do get into that a bit. Like, so if you end up forgetting or mixing them up, you can always kind of come in here and see some nice examples of what's going on. I believe this is going to show like a group, maybe. I don't know, you can do a lot of really cool things with not very much code. I was looking at some questions here. Or chats. So the Curran's question about interactions regenerating the entire viz, animated transitions. Yeah, okay. Somebody typed the answer.
Stepping on each other's toes.
Yeah, I mean, one thing is in the context of observable, right, where the data flow updates the cells, like re-render. You can use plot outside of observable, of course, and but the library itself doesn't currently support, using D3's transitions or anything to reselect marks. It's not optimized for that. Was there another question? The marks, I think, like, because we're at, we've been going almost an hour and a half, so we covered all the questions I think we set out to do. There's some a few more in this worksheet. One that I'm particularly excited about, I'm not going to focus on the code, but I would encourage people to try to make, is this like weather emoji calendar thing, which is just like really fun and not super tough to do once you've got all these pieces together. The question before sets you up for that. Like, there's a different mark, a cell mark. But yeah, I encourage folks to try this, and again, let us know how it goes, and if you have more questions, that sort of thing. So maybe, yeah, we can use a little bit of time now to take some questions from folks. What do you think?
Yeah, that sounds good.
Well, and someone did ask, can the plot be saved as an SVG, which can then be used for transitions? I suppose so. You can definitely save it as SVG. Again, it's being answered thoroughly in the chat. So next question.
Yeah, maybe before we, or sort of as we're waiting for questions, we can zoom out a little bit and think about what we've covered in a relatively short period of time.
Yeah.
We have this new visualization library, right? And we've both been D3 users. There are other great packages like Vega Lite. I've worked a lot in R with ggplot. And what we have is something that brings in a lot of strengths from those different areas, and have shown it with some pretty concise syntax what we're able to do to sort of open up a data set and walk through these visual exploration questions about distributions of variables, relationships between those variables. And I hope that this is part of making visualization easier, right? The barrier to entry for using D3 is still really high, right? It's a huge cognitive load and it's time consuming. And what I really like about this package is, for a lot of the simpler plots, you have this concise and hopefully even readable code syntax that someone with little or no background in JavaScript or visualization can come in and start making some of these plots. Yeah, what are some of your thoughts, Ian? Like, even just reflecting on moving through this over the last hour and a half.
Yeah. I mean, to me, the thing that just continues to strike me is the quantity of visualization that I can make with plot. Like, so, it's a combination of the design, the defaults, the syntax, like, but it's so easy to get a little bit going and makes it easy to like keep going. And then, you can, as we saw, we flipped dimensions. We like threw in a facet. We switched out like the transform. Like each one of those things is just another look that you get at your data set that you get so quickly. Like you don't have to really, especially once you've sort of practiced plot a little bit and you kind of get used to like, you remember what the different API functions are. And, you can just make, I don't know, I've done a couple of notebooks where it's just like in less than an hour, just making like 12 visualizations that if I were to have done them in D3, I would have gotten like maybe one, right? Because you're just not thinking about the rendering. Now, D3 is awesome, super powerful, and there's a lot of aspects to it, but like, because you're spending so much time thinking about the browser and the DOM and not, like, it takes away from the time that you have to think about the data and what you're seeing. And I think that's like the real exciting thing for me.
Yeah. So another question in the chat here: what is the value of using multiple languages for data viz? I have some experience with R. Why dive into D3 or plot? For me personally, I previously had done most of my exploration work in R because ggplot was this really fast, easier syntax for creating visualizations, and the tidyverse is great for data wrangling. But then it sort of stopped and lived on my computer. And once I had a good chart, if I wanted to collaborate with someone or share it with someone, I was emailing it or putting it in a Slack message. And what I've really liked about trying to shift more of that initial exploration into JavaScript is that I can share it on the web, or I can put it in a notebook and immediately get feedback or comments or collaborate with someone. And previously, all the JavaScript visualization I was doing was once I decided what I was going to do. Right? This is the interactive or explanation or exploration I want to do. I would do that I would put the time in and like create some great, hopefully great experience or some sort of intricate experience. And now I'm really enjoying bringing more of that exploration into the browser here. Ian, do you have thoughts? Have you ever, I don't even know if you've used other languages for visualization really.
Yeah. So I've actually done a bunch of Python at my past job, and worked a lot with data scientists that worked mostly in Python. And we did a lot of sort of doing some of the, especially working with larger data sets, like processing or machine learning models, like doing a lot of that lived in Python. But every time we wanted to show that to other people or to explain what it was doing, which was often we wanted to use the browser, right? Like it wasn't tenable to like get everybody, I don't know, either get people into a virtual machine or get things set up and running. Like if you have a browser, someone could be on the phone and see what's happening right there, right? So I think now with plot, especially what we're trying to do is make it so that you can do even more of that data thinking that you might have had to reach for in other languages in the browser. So like you might have already wanted to come to JavaScript D3 world to communicate and make visualizations, but we're trying to make it so that you can also do more exploration and make that easier to do. So I don't think for anybody working in these other environments, most likely you'll continue to do that. But hopefully now this will make it easier to explore and communicate when that's also what you want to do.
Great. There have been two questions by Zykel, Zykel, Zykel. it would be interesting to explore a little bit, if we want to take a little bit more time, this earlier one about how do you usually go about inspecting a data set for quality issues, like missing values in plot. That could be one thing that we sort of poke at one of these data sets for a little while and try and uncover that. And then this second question about adjusting the colors. So if we want to start showcasing a little bit more of the color customization, or even better, Ian, if we do both at once, can we showcase some data quality issues while leveraging some more robust color options?
Right. Well, I think maybe we'll take them one at a time. I think, well, so the data one is important. I mean, we hit on it in the stream in that, like, we visualized something and we saw something we didn't expect, right? And I don't remember if we included that. Maybe we can quickly
recreate that.
We have an extra cue here. I don't know. Yeah, so for this one, let me just copy paste it without the filtered data, because this is what happened to us. And I think that honestly, this is also like a really powerful reason to do this as well. Like plot and exploratory data visualization is that once you start looking at your data in these different ways, and you're not just trying to scroll through a list of text, you start noticing things that are off, right? Like when we thought, okay, penguin's biological sex, like male and female, and then there's this other column that doesn't have a label, that tells us like we weren't expecting that. We were expecting 2 columns and we got 3. So what's going on, right? And the next step then is to go and look closer at these data points. I remember actually somebody earlier did ask about tooltips, and we didn't answer it then. We're working on a tooltip plugin, and like the design of default tooltips is underway. So that's something that should get easier, but that would be a pretty traditional way of like, why, what is the sex of these penguins? And then you look at them and you see that they don't have one. So that's one way to get data quality. The other is to use more like the straightforward, like the table, right? So that is how we can see, okay, like there's a blank row here. You can spot check. You can use JavaScript to like programmatically check for things. Yeah, do you have any more you want to say on that?
Yeah, I was trying to, if you scroll down just a little bit, just made a little histogram of one thing, just of the flipper length. So maybe it was just right below that. So something when I think about data quality is just looking for extreme values. Like if there were a penguin where there were, I don't know, their flipper length was 80 times any one of the other flipper lengths, maybe that is something pointing to like a data entry problem, some typo in a spreadsheet somewhere. And what I would think of here is just how do we leverage interactivity to quickly search through these, right? Like if we're interested, again, we can create a view of a, I don't know, histogram variable is a select menu where we're looking at the columns. Some of those will make more sense than the others, but if we just here put the histogram variable, well, we can quickly click through things like bill length and bill depth. Oh, what if we make also a facet variable? Can we do that?
Ooh.
Right, some of them obviously won't make sense. So really the only things that we could reasonably facet by would be island and sex and species. So what if we have this facet variable and inside of here we say facet and we facet along the x direction with the facet variable. Oh,
you need to pass data
to data. Yeah. So now we've got these 2 things that we can check. And we can quickly say, well, how is this distributed across the sexes? How is flipper length distributed across the islands? How is bill depth distributed by sex? And these would prompt domain questions, right? I would want to go and do some background research on these different penguin species to check any of these assumptions. Like, why is it that the bill depth is, there are just very few penguins that are of an unknown sex? Looking for any other sorts of interesting observations here. But this sort of quick visual inspection is what I would try and do with Plot here.
Nice.
Except Ian, we're showing your screen and you're not looking at my.
Oh, I thought you switched over to.
Oh no, I've just been showing. I just assumed that you were looking at the right thing. Here's what I was showing.
Oh man, I'm sorry.
That's okay. So I'm not sure when you switched tabs there.
My bad, y'all.
That's okay. It looked like you were not looking at anything inappropriate here. So
no, I was getting ready to answer the next question. Is why.
Yeah. So here's what I had put together there is that I created a way to select a histogram variable. Maybe we'll give this a little label variable to histogramize. And then we also have this other facet variable. Why don't you like my label? You need an object.
Yeah.
And then we can use these two in conjunction to try and understand whether or not these distributions are what we would expect, right? How is bill length distributed by sex? How is it distributed by species? How is the bill depth distributed by species? So this sort of rapid visual inspection is what I would do to try and understand it.
Very cool.
Yeah. All right, I'll put your screen back on. It's all you.
Yeah, so I'm answering YSU 91. You're welcome for the session. They said thank you for the session. But they asked, do you have any debugging visualizations in Plot? Can you use the JavaScript debugger? So you can use the JavaScript debugger. I haven't actually tried it. An interesting side effect of Plot is that because of the defaults and the way that it's always showing you something, you can almost do this visual debugging where like you tried something and you see it's not what you wanted, so then you try something else. So for me, that's been a really interesting change of pace, because in D3, you're not just working with the data, you're working with the DOM. And if the DOM doesn't like what you said, then you don't get anything. But here, we're often just like, and I'll show you an example. Like this is a stack chart where the stacks are kind of out of order. And I made like a simple syntax bug where I'm like, instead of doing, I think, stack or bin Y, I did bin X or something like that, right? But to like take it a little further, there are ways to ask Plot to tell you what it's calculating to an extent. So there's this initialize function, which will kind of show you the channels that are set up for the mark. And then there's a sort of experimental function Phil helped with to show what a transform is doing. So if we want to see what the bin X is doing to the options that get passed into the rectangle, you can call this, and it will show you like for example, the X1 and X2 channels are like the start and end of each bar. And you can see that those values are like these bucket things, whereas like the Y value will be the height, the data of the Y domain for each bucket. And by looking at this, sometimes you can see that it's either missing dimensions. So I think in my example down here, if, this is wrong, you look at this and you get like a y1 is undefined, like that's probably something you want to see, why is that not giving me that? So there's a mix of things you can do. You can always go into the code to see what these things are doing. There's different, I guess, levels you can dive into. So this I put into the chat if people are interested in that. It's a little bit more, digging into the code side, but maybe interesting.
Awesome. We lost track of that question about colors. Ian, do you think we can find something that will allow us to showcase a little bit more color customization?
Yes. So I'm going to take the solution here and put it here. I'm cheating, do as I say, not as I do, as my dad used to like to say. See, so the fill is the species, right? So the fill channel, we can customize with the color scale. So channels have scales associated with them. So our color scale, we can override in a couple ways. There's the domain and the range. Now, this is, if you've used any D3 scales, this will be familiar. For example, let me do it the most manual way. So the domain, again, we have the species. So I don't know if I'm spelling them right. Adley, Gentoo. I know Gentoo from the Linux thing, but these are islands. Can we make it? Chinstrap. Should have these memorized by now. And then the range, we could say like red, green, and blue. That's going to be really ugly, but like, right. So the idea is that the Adderley penguin is red, the Gentoo is green, and the chinstrap is blue. So that's one way to customize. If you change the order of this, right, like I could reverse this array. If I change the order of the domain, keep the range the same, then the colors are going to be different, right? So now the chinstrap isn't that, right? I don't remember, but it should just be the opposite order of this. Typically what you do, and it was linked in the chat, you can, instead of saying the range manually, you could define the scheme. And I think there's a bunch of, by the way, this is what I do. Like I open the README and I just like Control F for stuff. So like definitely do that. So there's, there's things like category. I think Tableau 10 is the default. Let's change it to something like accent. Okay, it's very faded or very light. I guess that's why it's called accent colors. Dark 2 sounds like fun. So yeah, there's going to be a number of these schemes that are built in that you can just reference by name. Now, does that, I think that covers the color question, right? It was about how to customize and maybe change the order, which we went over. Missing anything?
That sounds about right.
Yeah. Interpolator in the weather calendar chart is a good example too. I'll just pop that open real quick. So if we go down to this one, yeah, the weather calendar, I copy that here. Using a colors channel to, the fill is precipitation, the color scheme is blues, so it's using one of these named ones. So like we could, I don't know, let's use Inferno. It's always dramatic. There's your Seattle precipitation. So you can see why we went with blues. Yeah. And you can, oh, that does remind me though, you can change the type of scale. So there's like square root scale, logarithmic, but something like square root will emphasize, sorry, I'm not sure exactly how I want to phrase that. It's easier to see on a line chart. But regardless, you can see the types of scales. And to read more about scales, go to this notebook. Oh yeah, the how to customize the calendar visualization notebook is great. Somebody, E2Dev took that exercise and like really took it to another place. Nice. Let me just open that real quick. It went from, this is the example, changing the colors. Oh, look at that.
Nice.
Definitely in the
Inputs.
Spirit of what we're talking about. Oh, good. Okay, that's going to do it for everything. Put it back to blues. And then they split out the months. Look at different ways to format the like axes, customize the ticks. And so actually this is a great notebook for seeing, yeah, really practical ways to deeply customize a lot of aspects of the plot. And the end result, I'm going to get to, I think this is the last. Yeah, it's pretty interesting. This is more like a wall calendar view, which is pretty nice. So.
Incredible.
Yeah. Wait, carrots and pizza, is that you, E2Dev? Very nice. Very nice work. Yeah.
What do you think? Should we close things out?
Yeah, I think nice. Yeah, we're reaching the end of overtime here. Yes, thanks for that banner. We do have an upcoming event in a couple weeks. That should be really cool. Hopefully people will check it out. Focused on different kinds of visualizations we're working on, and we'll have more events in the meetup, more streams coming up. Some of our ambassadors as well, right?
Yeah, coming up in a couple weeks.
Yeah.
Those events should be created shortly.
Yeah, it's really exciting. Yeah. And oh, the one thing I wanted to mention is that, I mean, some folks probably have seen us stream before, or, you know, for those that are new to Observable or are noticing some cool changes, we have been shipping some really nice features. So the collaboration, that we're able to edit the same notebook. You might notice that the interface for editing cells is different. You know, shout out to the Markdown cell that lets you just say that without writing any code, like that. So I just wanted to give that a little shout out. It's some cool stuff.
Yeah, well, this has been great, Ian. I really enjoyed seeing your workflow through this. You're definitely the relative expert here on all things plot, and hearing you talk through this has been really helpful for me. Hopefully, this process has been great for folks joining us to see how we can use these mental models to then quickly build our own charts. And we hope that folks continue to join us and leave comments in these notebooks. Let us know how these learning materials are. And we are hard at work making more resources to make visualization easier to get started.
Absolutely. Yeah, thanks. And thanks for teaching as well, and showing us some cool different approaches. I mean, for me, relative expert or not, I still feel like I'm learning every day and every time we do this. So it's just exciting to be able to try more things faster. I definitely would love to hear from folks on what they're excited about, see the notebooks that you're making. but definitely what's hard and, what's challenging, because that's, like I said, Plot's still early in development. We're trying to make it easier to use, make more sense to people. So that feedback's super helpful. I did see someone ask again if the video would be recorded. It will. It'll be both on our Twitch as like a recorded session, and we'll post it on YouTube soon after. Yeah. So thanks everyone for joining. Excited to see what you visualize with Plot.
Thanks for coming, everyone.